All right. So sorry for the overhead here, but I think we will get used to this. So I sent out a note last night about the agenda today. So we will use that note as the guidance for the discussion. First, want to give a quick update on the overall status. So so far, a group of companies has been. So, I'm not talking, please mute. That too. Okay. All right. So a group of companies has been working pretty closely on about a weekly basis in the past 4 or 5 weeks ish. So far we have been making continuous progress, and in a few major areas we are trying to do more converge. I think in the PL area we are in fairly good shape, but we do need to push it to the final agreement. And also in the mechanical area, we are making some iterations. Overall, the overall concept has been pretty close, but there are many details to be worked out. And over the specification, earlier we target to get a specification written actually today. But currently we are not seeing the progress as we wish. A few major areas as one thing is mechanical did need more time to converge on the detail itself, especially on the guiding and the latching feature, etc. And then with extra time to write on specification. And on the pinout area, actually, Intel, especially Thomas, did a lot of work on in this area, and it's probably in the best shape of all the chapters. So there's a good base to review. And I put some time in the overall section. I will also put them up for the review. So I'm thinking about maybe after today, earlier I actually wanted to upload the file to the wiki, but there was some problem with the file sharing yesterday, so I will do it anyway. But if we have any change today, we can just take the change, and so that the whole working group will be able to see what the spec look like today, and especially also like about the chapters, the content. And then I will do more follow-up with the owner of a few other chapters to see how do we close it in. So tentatively, I'm trying to set a time by the end of the month to have the first edit of the chapters done, except that with the mechanical, if we need more time to agree on what it is first. Yeah. So that's the overview. I will pause a second for questions on the phone. All right. There is some background noise. How do I see where it's coming from? If you are not talking, if you can mute.
Hey, yeah, this is Rich. Last meeting, the TE guys said, can you hear me?
Yeah, Rich, I can hear you well.
In the last meeting, the TE guy said they were going to present the collateral for the straddle mount connector. Is that still on the agenda, or is that moved to the next meeting?
Arash, if you are here, feel free to speak for yourself. Otherwise, I will answer Rich. Let's see if Arash is there. All right. Yeah. So on my email change with Arash, he has some concern of displaying the straddle mount mounting structure on the call. So, but he will try to call in from the next session from 10 a.m. Depends on the agenda and discuss over there. So the short answer is they for whatever reason, Tycho is not able to share the screen here.
Okay.
Yeah, but in top level, we are working toward the straddle mount. That's kind of one of the mechanical topic, but we are working toward reducing like 3 millimeter, like 1.5 millimeter on each side, so that we can reduce the large size from 142 to 139, and this will meet Dell's platform requirements. And Josh, you may comment on more in this area, like how much potential you see on the connector itself.
So the concepts I've seen from TE, I think get us there. I haven't seen the final versions though, so I was going to defer to Arash to provide those final footprints. Until we see those, it's not a done deal, but I think they're very aware of our concern about the overall width of those connectors in particular.
And by the way, I want to clarify, this will not only change the largest form factor by 3 millimeter, but also the medium one, right?
Yeah. So both the large and the medium will change. The small size won't actually change because the small size form factor is actually driven by a 4RJ or 4 SFP, and just in terms of the stack of fitting everything, just on the front of the piece.
There's only one connector, so it doesn't really matter.
Right.
There isn't a cap to review. Right. Rich, does that answer your question for now? Kelly, if you can teach me, how do I see who is speaking, or like who is making the song?
If you pop open your audio tab, it will show you at the bottom. It'll say talking. Right now it says OCP webinar, which is me. Or if you're looking at the attendee list and someone is speaking, it'll show like a sound a microphone image by their name. Archana, are you there? Maybe you can start speaking and it'll show him how it looks when an attendee is speaking.
Yep, sure. Can you hear me?
See how it looks like a microphone?
It looks like a microphone which says that, to me, yeah, it says that I'm on, but then there's a little speaker with a volume thing on it next to me under the attendees.
Yeah.
Can you see it?
Yeah, because she's talking. And then these are the people that they're not muted basically.
And again, if you pop open your audio tab, it'll say at the bottom talking, and then it just actually lists the person, which is also an easy way. But as we go, if you chime in and maybe you haven't spoken yet during this call, just go ahead and announce yourself just to make it easier for everybody.
Yeah, this is John Sturley. I do see sometimes talking, but sometimes it doesn't show up at all. And in the attendee list, I don't get any kind of microphone to see who's talking.
The only person that we see talking is OCP Mezz, OCP, or it's ourselves. But as attendees, we don't see who else is talking.
Okay, so let's go ahead and just, like I said, just announce yourself, your name before you give your comment.
Okay. Thank you for the question, Rich. Is there any other questions for the overall status before we get into ping out mechanical topic and ping out the thermal?
No, thank you. I was muted. I understand the status of the connector now.
All right, thank you. Yeah. Okay. Josh, do you want to jump into some mechanical topics?
Sure, we could go ahead and do that. I don't actually have that many updates from our last Friday mechanical only meeting, but for the benefit of some people that weren't here, maybe I should at least just touch on those points.
I think there are many people that are not attending the working session.
Okay, that's fine. So we'll just go over it briefly and kind of where we're at. And yeah, so let me set up a share screen here.
Or I can just do it.
I think you need. Oh,
I'm already sharing screen.
Here, let me send you my updated.
Updated one?
Yeah.
Sorry. Are they in Dropbox?
I'll just send it to you.
You haven't logged in, right?
No, I'm logged in.
Yeah, okay.
I can share.
Maybe you can share that. Yeah. So you're logging in with your name?
Yeah.
Eddie, do you mind? Do you mind set up Josh as the
presenter.
The presenter, yeah.
Joshua Held.
Correct.
Yep.
Thank you very much.
You should see a box pop up, Josh. That'll you can click share my screen.
All right, I see it now.
There you go.
Nice.
Cool.
Great.
It actually. Okay, so just for the benefit on the phone, people on the phone, last Friday we had a kind of a pure mechanical thermal get together. I did make some updates to my slide since the previous meeting before that. But let me just launch right into it. I'm going to only skim over some of the things that haven't really changed from my perspective. So this is the general NIC v3 auto configuration at Facebook, and it's being presented from the Facebook OCP side. It basically has a module that.
Oh, this is my share.
Wait. There we go. It basically has a module that's pluggable from the back panel or front panel of the chassis, a couple card guides, and this is just shown as a straddle connector. We also have a right angle connector available as well. These are basically sliver TE connectors, and the width we were just talking about has to do with the width between these ears, which becomes more critical for the larger form factors. So this is basically a mechanical goals. This is the mechanical goal that I've had mechanically through this process, to develop a universal form factor which shall include mechanicals and EMI containment. I think that the point of this goal is to try to get us to a place where we're all not creating custom mechanicals every time we go to implement a NIC in our systems. This is something that's very painful for all of us, and as well very painful for the NIC vendors. So we're trying to get to a point where we can all kind of leverage a similar architecture across the board that's usable for everybody. From this goal, there are several requirements that kind of go into this. These are the requirements. I'll just go through them quickly. The same NIC design must work in both straddle and right angle configurations. Since we have different connectors, we want to be sure that the modules we develop can plug into either. We don't want to have special modules just for a right angle configuration, for instance. NICs might be oriented horizontally or vertically. Retention and guidance must work with specified NIC v3.0 motherboard thicknesses. Today we have several motherboard thicknesses. We have 062, 093, and an intermediate, I think, at 079 today. I'm not sure what we agreed on. 76, something like that. So we have to make sure that all of these features work with those motherboard thicknesses. We'd also like to have common mechanical features used across all small and large form factors. The purpose of this is to really make it so that in terms of implementing, it's very straightforward. We don't have special features for special use cases and things like that. It's very cohesive design language that goes into this. Some form of mechanical mechanism is required for seating large form factors due to mating forces. Some of the larger form factors have quite a few contacts. They drive our mating forces up to close to 29 pounds. So we definitely need some sort of mechanical feature for that. Design of the PCB should be flexible enough to support many component and connector configurations without need for mechanical changes. Again, we really want to provide stability to the NIC manufacturers so they can do a better job designing NICs that we need and not just designing variants of single NICs. We want to get out of this pattern of them having to have 50 different types of NICs in order to support the customers. Recommended mechanical designs will be included in the specification to simplify and reduce barriers to adoption. Again, we want to get away from custom mechanicals and make it so that a mechanical engineer or anybody wanting to adopt NIC v3.0 has a very low barrier in order to build these into their systems. So, unless I have any questions, I'll move on. Can you use me?
Also making myself.
Oh, Josh.
Yeah, I think this is the point.
Okay. So I'm going to move on.
So these are the survey results for the surveys that were provided out to the community. The partners have been obscured in this view, so just to keep this nice and private, there's some proprietary information in some cases here, so we want to keep that private. So one development from last week was Lenovo did agree to the 11.5 millimeter top size keep out. So as of right now, we have Dell EMC, Facebook, Lenovo, and Quanta all agreeing to 11 millimeter top side keep out as well as 2 millimeter bottom side keep out. 11.5, excuse me. That half is important. So yeah, so we're having pretty good alignment there. HPE, I believe, is still biased, 11.25 and 2.25. So technically, they meet the 2 millimeter bottom side keep out, but I didn't want to mark that for them until they had additional time to look at the current keep outs that we're proposing. So another thing that we've added is there's an insulator at the bottom of the PCB to protect components on the bottom side. So the 2 millimeters shown here actually includes some sort of isolator. I call it a 1/4 millimeter thick isolator because that's what we're using today on NIC v2.0 NICs in some cases. The purpose of that isolator is to prevent shearing of components as well as grounding to chassis and things like that. The 11.5 millimeter keep out, you can actually run all the way up to the top of that keep out, and it includes all the faceplate surface as well, except for the EMI gaskets, obviously, that need to protrude up in order to provide the correct grounding. One thing I've looked at in the last week are some of the requests around very many ports for the large form factors. Some of the partners wanted 4 to 8 RJs. The case of 8, I think, is going to be a hard sell with the latching mechanism. We could possibly do 6, but this needs some additional study. It's been kind of on my back burner, but I did have a chance to look at it, so I do want to tell the community that. Something I'm still working on. So unless I have any questions here, I'm going to move on to the next slide.
Oh, sorry. Yeah, I don't want to point out the 2 millimeter. Pretty much we realize this is too marginal. Our current analysis shows risk of the current sector.
For the right angle.
For the right angle.
Yeah. So I guess I should talk about that. So in last Friday's call, basically all the mechanicals on the call agreed that the current 3.05 centerline distance of the current right angle offered by TE is just too low. Basically, when you do the tolerance analysis, just basic tolerance analysis of it, it basically means that when the card's biased all the way, when the cards at the negative side of their tolerance were basically isolator on PCB with 0 clearance. So I think that was a bit of a surprise for TE on the call because I think when they determined that size, there was discussions going with I think Dell and HPE primarily about the height of that connector, so this did catch them off guard a bit. We have asked them to look at making that solution a bit higher. The numbers that I think make sense is going from 305 to 3.5. It's a big enough jump that probably makes sense for them from a product line standpoint, and it also buys us the required clearance that we should need. It buys us about 0.35 of clearance. Well, we're only going up. We're only going up 0.45. Yeah. Okay. So, but okay. Yeah, it buys us some clearance. It's still not a lot of clearance, though. I mean, we're talking, 20 thousandths or something like that. So, less than half a millimeter, basically. So that's one thing that's ongoing with TE. Any questions about that? I think we already talked about that earlier, but that's a little more detail there. Okay. I'm going to move on to the next slide. These are some of the mounting variants. So keep in mind, these models are actually quite old at this point. I do have updated models. I haven't updated these images. The cards guide configurations have changed somewhat, but the thing to take away from here is we have basically straddle mount versions in both small and large form factors. We actually have 2 large form factors that we're considering right now, and we also have a right angle variant that looks like this. The right angle variant, the big difference is there's not a large cutout under the NIC, so you can actually route traces under the NIC itself. And this is the large variant for the right angle. Okay, there's a bit of blood. Okay, so I'm going to go through some of the components of the variants. Basically, the Facebook proposal, it has very basic components. It has a very simple faceplate with finger stock applied to the bottom and the top. We have the NIC PCBA, this is our mock-up of the NIC PCBA, courtesy of Quanta. And these are our card guides. So the card guides would be available in either a straddle version or a right angle version, and they could be pressed into the PCB. They could also be screwed, basically mounted with screws. In this case, for the purpose of these prototypes, Quanta actually used a small internal threaded brooch to screw these to our PCBs. That actually turned out quite nice. And these bosses are quite a bit bigger than they need to be to actually implement that fix. So the general BOM of the complete solution kind of looks like this. You have a PCBA, you have a faceplate, you have the gaskets applied to the faceplate, you have a couple screws mounting the faceplate, you'll have an isolator on the bottom of the PCB, and then on the system side, you basically only have a couple components. You have your card guide. There would always be 2 of those. You'd have your screws if you have a screw-in style card guide. You may not have screws as well. And you'd also have your connector on your motherboard. I don't know that I need to go through all this stuff. Okay. So are there any questions regarding that at all? I think this is pretty straightforward, and it's what we've been talking about all along, so I don't think there should be too many questions or concerns.
The gasket, is that the EMI finger?
Yeah, this is the spring finger.
Got it. Okay.
Yeah. That's why there's 2 of them. Okay. So we also have different module variants. So this doesn't actually get all of them. This is just kind of a small subset of what we're dealing with. So we have our small form factors here, and these are basically sized to take a 2 QSFP, 4 SFP, or a 4 RJ. You could also have, a single port QSFP, a 2 FFP, a single port RJ, etc. These are just kind of the worst cases in terms of space usage. So that's what we're really evaluating. And then we also have latch versions of both the small and the large. The latch is somewhat limited use case on the small because it largely depends on how much faceplate space we have left after we place our connectors. So if you had something like a 4 SFP or a 4 RJ, this would not work because we physically don't have the space to implement our basically latching mechanism here. This is a large one. This is just one of the large form factors. Some people want to call it a medium size, but this is just what's shown in the slide deck, and it's very wide. We have a latch for mating force concerns. These are the mating forces that correspond to the different large sizes. So the small size actually has a relatively small mating force. It's about 14 pounds. And that's just due to one 4C connector plus OCP bay. We also have large size 1, which has a 4C with OCP connector, just like the small size, as well as a 2C. And that mating force comes in about 21.6 pounds. Large size 2, it has even a bigger connector. Instead of the 2C, it has a 4C. And this provides a by 32, where this one provides a by 24. The mating force there is about 26 pounds. So again, we need some sort of mechanical advantage in order to make those cards entirely. It's pretty high mating force. The unmating force is relatively low for these connectors, so that's not too much of a concern. But my concept still is built an injector into the latch mechanism because it was pretty convenient to do.
This is Warren Bailey. Can you hear me now?
Yeah, I can hear you. Any questions, Warren?
Yeah, sorry, I tried to speak earlier when you're on the chart showing the configurations, and the table that showed the stretch goals for how many connectors can be across was listing a stretch goal for 4x10G base T, but not a stretch goal for ports of RJ45 1 gig. Why is there a difference there? Because width-wise, those should be the same. See, it's got the asterisk.
Yeah, so maybe I should explain this table a little bit more. Basically, I don't know if you saw the survey. We basically had 2 columns. We had a 90-10 column, which basically means you're definitely going to deploy it, and then we had a 50-50 column. So these I didn't change the responses of the either NIC manufacturers or system vendors at all. So so for instance, this case, if you look at this column C right here, oh, I can't highlight that actually, sorry. So if you look at column C or row C, they had 4 SFPs or 8 SFPs as a stretch goal, and they also have 4 and 8. So these are different responses from different vendors. That's why what they're asking for looks a little bit different.
Okay, so stretch goal isn't mechanically whether it can be done or not. This is the usage information, potential
right,
usage.
Yeah, exactly. And today, this is what I'm driving to today. Like I mentioned earlier, I have looked some into the width of say the 6 and 8 ports for a RJ. The 8 port is going to be very difficult just from a space usage perspective. The 6 port might be possible. So I probably need to update these at some point. I just haven't gotten around to it. So this is what our current guidance is, this last row right here.
Okay. All right, that clears it up a lot. Thank you.
Okay, cool. Any other questions regarding that? Okay. So I'm going to move back. Sorry I kind of blew past your question there, Warren. Feel free to chime in if you guys have any questions. Okay, so I'm going to skip from this slide down to the next slide. So one of the things that the community's been very concerned about is the width of the Facebook proposed solution. So last week I presented this in the mechanical only meeting. Lenovo actually generated a concept that actually had a snap-in feature at the front of the card guide, which did help narrow the form factor somewhat. And so here's a table that explains kind of how the widths work. So my original concept had a faceplate width of 89, and behind the faceplate is about 92.75, partially due to it's basically the width of these bosses here that stick out in the straddle case that was concerning for the partners, because they couldn't put connectors very close to the NIC. So what I've tried to do, and what Lenovo was trying to do, was trying to reduce the overall width of the package so that we could fit more connectors on the motherboard right up adjacent to the NIC. So so from the Lenovo card guide, and as well as optimizing the faceplate some more, I got down to 87 with their proposed solution. And I also did another narrow card guide solution, which actually changed the configuration of the card guides somewhat, as well as removed all venting from the faceplate of the NIC entirely and pushed the PEMs all the way in, just adjacent to the 4RJ. And that got us down to about 80 millimeters of faceplate width, as well as 80 3/4 of a millimeter of card guide width on the inside. So you could just squeeze not a particularly deep connector in this case, but you could squeeze a connector up to the edge of this. I could probably also still move this boss back some to provide some additional space there. So the changes involved in creating this narrow concept included new card guides. I removed all the faceplate venting, pushed all the thumb screws in, and I reduced the heat sink width by 5 millimeters, and I also changed the chassis opening. The one downside to this concept is that it provides a it provides a non-rectangular keep out basically at this point. So in order to retain the nick in the chassis, I need to have the chassis pick up these screws, which means that the keep out area now for the nick has to be so the keep out area for this nick now has this notch taken out of it here. So on the bottom side, we have 72 millimeters of available width in between the card guides, and we have 2.5 millimeters of height, and then the keep out narrows at the top to 63 millimeters, and that goes all the way up to the 11.5 total keep out. So the keep out is a little more awkward. It's not as straightforward as it was previous, where the previous topside keep out was basically 72 millimeters all the way across, and it went all the way full height. It didn't have any cutout here. So this is the trade-off of this very narrow design. Okay, any questions regarding these concepts? Okay. So one thing that I worked on yesterday a bit, particularly with the large form factors, I'm getting concerned about kind of mating forces. So
just sorry, quick question on the heat sink width reduced
5 millimeters. Yeah.
What was it before?
I want to say it was 65 and went down to 60. So it is at the very outside perimeter of a heat sink. So we kind of have reducing efficiency when you get out towards those edges more. So I don't think it's going to hugely adversely affect the overall cooling of the package, but it is smaller. Keep in mind, this is for the small form factor where you physically can't put very high powered ASICs on there anyhow, just from the cooling constraints of that card. So I think it would be okay, but it's definitely it's something that's different. Okay. Okay. So one thing that I've been playing around with was particularly for the large 2 form factor, the one that's even wider than this is kind of hacky. I know this doesn't look great, but the idea is that with the faceplate architecture that we're proposing, we can actually do a proper ejector and latch on both sides. So it'd be like a proper module. So it'd provide, it would basically allow you to secure both left and right of the very wide form factors. And we can definitely optimize the touch point size and possibly put these vertical to provide more faceplate space. The original concept just has a single latch here. And the single latch I'm a bit concerned about, particularly in the wide form factors, that it's only really retaining one side. And it might work, but we might also have some problems with that. So I just wanted to make the community aware that this current architecture actually allows you to do this very easily with a small faceplate change. All the mounting's all the same. You just implement additional latch. Yeah. So again, it's a bit hacky, but we could definitely make this look quite a bit more elegant with a proper, some sort of proper spring latch or something like that that would pick up the faceplate area. Okay. So this is our current sizing details. This outlines, this actually should be early in the slide deck. Sorry about that, it's a bit confusing. This table outlines our current sizes. So we have our small size at 76 by 115, our large size at 120 by 115, and our large 2 at 142 by 115. Again, large size 1 is a by 24, and large size 2 is a by 32. that's pretty much what it looks like. In the Facebook OCP proposal, we have a 2 millimeter keep out that runs the length of the side of the card. This is for basically picking up the card guide itself. The one nice thing that's good about this keep out is we also have a keep out for the component placement anyhow at about 1 millimeter. So we are kind of leveraging that keep out that already pre-exists there. So we're only about 1 millimeter in from that 1 millimeter SMT placement restriction.
Hey Josh, this is Rich. Is the objective to go down from 3 sizes down to 2 sizes, or are we thinking that we need all 3?
So this is actually an open question for the community, and this is something that Jaw's been asking. We would very much like to go down to 2 sizes from a simplicity's sake, and we wanted to kind of get some feedback from the community if the by 24 is something that is wanted. If it's something that you guys have use cases for and can use due to the narrow width, we'd be open to keeping it here, but we would like to simplify down to 2 sizes if possible.
Are you planning to do a canvas the community to see if there's a particular this decision that can be made?
So we kind of already have.
Okay.
So in the survey, a lot of the feedback for the use of there was a question at the bottom of the survey that basically said, are you planning to use the large size NIC? And kind of embedded in that question, a lot of people provided feedback to what sizes they use. So we do actually have one system vendor that is interested in the by 24 due to the size. They have a form factor that cannot physically take the by 32. So these were kind of the results, and this is our current guidance right here. Is we're considering both by 24 and by 32. But yeah, we have got some feedback.
Okay.
Yeah.
I think it's largely a system limitation.
Yeah.
If saying all the systems can accommodate the largest form factor, yes, it doesn't make sense to have a medium one. The need for a medium is from the system side. The next side will always prefer a larger one. If there is.
Always pretty cute. We know what you guys wanted. The issues on the system side.
But the NIC, I think, also wants fewer choices.
Yeah,
that's a theory.
Yeah.
Agree. Yeah.
Sure.
But I want to drill down a little bit more. Like for a NIC, if there are 3 choices, would you still try to implement it in the smallest one possible?
We would definitely implement the smallest one. I feel that there's a big market for the smallest one, both on what I'm hearing from the system vendors, saying that they got a space for the smallest one, and just overall that makes sense with what the industry wants. I'm not going to take my product that can fit into the smallest, not doing that.
So how about between the 2 larger one, would you try to implement into the smaller of the 2?
So the challenge of the medium one is for the ideas that we're thinking that go into the biggest one are really go big ideas, either in terms of massive power or where there's really a use for all 32 PCIe lanes. So the 24, as a NIC vendor, I'm not seeing a clear place for it immediately. Now, maybe there's the possible place for the medium one is if there is a system vendor who's putting something in the hot aisle and we really just need a way to get thermals out. I wouldn't actually use those extra 8 lanes, but it would just be a way to get temperature out of the device for that system vendor.
Parallel cool the optics.
Exactly. I don't know what
so then I'm going to pitch the question to the system here is, do you see the value of the middle ground?
No, and in fact, I've talked to several of the vendors, right, and I haven't come up with a use case where I would use those.
Either go big or go small, basically.
Yes. However, I mean, you do get some advantages with the parallel cooling. for hot aisle operation, certainly. But you get those with a larger form factor, and then we have something that fits two needs. So,
Do you see the larger and small one are like in your platform? You see a good use of both.
I think there's a good use case for both of those.
Yeah. Okay. How about focus on the phone? Any system vendor want to chime in on the value of the medium size or the large one, so-called?
This is Warren from Lenovo.
Oh, yeah, go ahead.
I can't think of a good use case for the by 24. You can think of use cases for by 32, but by 24 is kind of an odd size for networking.
I think it's more from not only from a PCIe point of view, but more from the cooling and the PCB space point of view. Do you see any value? Like, or in other words, like if you're only given the smallest one and largest one, does it cause some problem? Like, do you have any platform that you want to have something larger, but you can't afford the largest form factor? That's a question to Warren.
Yes, I hadn't thought about this from a cooling point of view, but to have a by 24 available just to have more perforations in the back of the chassis just seems like an expensive way to go.
Okay,
it's a
sounds good.
motherboard space with perforation.
Okay, so in short, I can take Lenovo is okay with going only two sizes, right?
Yes, I think that's a true statement.
Okay. Okay, cool. How about HP? I see a few HP engineers on the bridge. What's your thought of having only two sizes?
James Schultz is usually covering this, but having talked with him previously, I know two sizes is the most of interest, with expectation that we really want to focus as much as possible on the smallest size available.
Okay, that's actually good to know. I don't see anyone from ODM side on the bridge, so I will reach out to them to see what's their investigation. As far as I know, they are trying to investigate getting the larger one into some of their platform. Okay. So they haven't get confirmation, but they see some hope.
Good.
There. Yeah. Okay.
I think with that we can hopefully strike the 24 then.
Yeah, we can. I'm thinking, let me reach out to the audience, since they are not represented here. But if there is unless there is a strong preference, I would actually call out just taking the large and small, and see will that trigger any more discussion. Yeah. Thank you for pushing for it.
No problem.
Okay.
All right.
Should we move on?
Yeah.
Okay. So the current RJ is actually one of the big limiting factors. This slide is probably more for the MEs really, so I'm just going to kind of blast through it. The RJ is one of the hardest cases we deal with, partially due to the size of the RJ, both from a vertical standpoint as well as a width standpoint. The width of an RJ is basically the same as a SFP cage, a 4x SFP cage, but this is our limiting factor in the small form factor. Today, what Facebook is proposing, Facebook OCP is proposing, is a 10 millimeter sync mount RJ that both Luxshare and Delta have today. John was kind enough to help facilitate that. So that's kind of where the designs are geared. Part of this height is really important, particularly for the latch cases. So if you have a smart NIC that needs a latch, some of the lower sync mounts, the 8 millimeter sync mounts, actually get in the way of the latch itself. So I physically have a tough time fitting it into the smart NIC vertically. So that was the reason to go with this. The other nice thing about going with this stack of height is it allows us to have a wall on both sides of the RJ with finger stock placed top and bottom. So we still maintain very good EMI sealing to the chassis as well as good grounding to the RJ itself. In my models, there's actually a hem both top and bottom to try to prevent the top side flange from bowing up due to the force of the grounding fingers on the RJ cage. So yeah, I guess there was this one open item about the 1x2s.
So there isn't a 1x2 that would work. However, if there's sufficient demand for one, both vendors are willing to go off into it.
Okay, cool. Thank you very much. So that's the RJ. So the vertical stack up, this was actually changed last Thursday or Friday when we realized we had this issue with the right angle. So my current guidance from the bottom of the, how do I say this? From the bottom of the PCB, the NIC PCB to the top of the motherboard is 2.75. This is approximate. So it basically adds 0.5 millimeter to the straddle case. So that was an update, and that has to do with the taller right angle that we think we need, that we discussed earlier. And that is pretty much it from my side. This is kind of what we're continuing to do. I have done some diaphragm review with one of our key ODMs. The feedback's been received, and they actually, there's only a couple items that they're concerned about. Some of the forming of the faceplates is something we need to work on. But I think in general, the concepts are very close to being, manufacturable at volume. So that's, why we're still proposing the same physical mechanicals. And we're trying to continue to close on keep out. So the keep out is largely closed. I guess we just haven't received any additional guidance from HPE regarding their vertical keep out top and bottom. The board size we're closing on, like we just talked about, we may drop the middle size, the by 24 size, and just support a by 32 size. So that's ongoing. EMI shielding, I think we're pretty much settled on. I think everybody agrees that the finger stock method seems to be one of the more robust methods to providing good EMI shielding. And the connector options are also kind of somewhat linked to the board size discussion as well. And I think we're doing a good job closing on that. In terms of connector options for the I/O, the only restriction we have today is the availability of RJs, and then we can't deploy just any RJ due to the vertical stack-ups that we're proposing here. So that's one of our restrictions. So with that, any other questions from the phone in the room?
I guess I have a question. This is Warren again.
Sure.
In terms of like conformance or compliance, is there going to be any kind of either a standard platform or something like that to test against? I know we're just basically using a PCI Gen 4 spec and everything, but in terms of either that or mechanical guidelines or anything, is there envisioned to be any kind of a common test fixture or something like that people can test against?
What do you mean, for like physical size, or what specifically?
Well, for both, either physical size or just electrical conformance. Or are we just going to say electrically it's just the NCSI specs and the PCI spec?
I think for NCSI, it's something that we're just going to say it's a spec. But for PCIe Gen 4, I think we have to develop a compliance board that kind of follows what the PCI SIG has done, so that you have a standard test methodology, both a load board and a base board, so that you can test the card outside of a system and you can test the system with without the card.
Okay, yeah, that's what I was kind of getting at. And I don't know if there's a mechanical aspect to that or not.
There's definitely going to be, I mean, obviously the one that goes in the system has to fit, but it's probably, you know, based on what we've done in the past, it's probably multiple sets of cards testing a certain number of lanes at a time. But it's something that we've been looking at a little bit, and we're not far enough along to bring it to the community.
Have you talked to Summit about it?
No, I have not.
Summit hasn't. Okay. Let me see if he has time, because he is interested with this topic. Okay. And he's working with a few suppliers from us to define this on the 2.0, Mezz 2.0. But we'll bring the methodology into 3.0 PCI Gen 4. Okay. So I will see if he has time today to drop by and talk to you about his thoughts. Sounds like you guys are trying to address the same problem.
Yeah, it's what we've done for every one of our custom form factors. We have a set of those boards that we can go plug in to have at least a baseline.
Right. Do you think it makes sense to like also work on this methodology and make it part of the like in the subgroup, so we have a way to have the same fixture to qualify cards, etc.
I mean, that's the real key, right? Is we want to take any of the vendor's cards and be able to plug it in our systems, and the only way to do that is to get it clearly specified. We won't solve all the corner cases, but we'll hit a large majority of them.
I think in these cases, getting 90 or 95% is kind of where you go for. You know, that 5%, you know, you kind of have to accept some variability at some point.
That's right. If you can hit 90, 95%, it's Miller time.
Yeah.
You go get a beer.
Okay.
And celebrate success.
Okay. Does that get to your question?
Yeah, thank you.
Okay, cool.
Hi, this is Abe Ali with Cavium. Sorry if I missed a point earlier. I understand that the draft is moving to mid-December. Is there a new date for the ratified version of the spec?
Okay, that's a good question. I think we need to gauge December, John, maybe I can get some help on John's doing. John, do you know on the December, will we still have a server work group call on the 4th week? Is that a holiday week?
Yeah, we probably need to discuss that. We haven't discussed that yet, but that's getting awfully late in December. We might be able to move it up a week.
Like 20th? December 20th, right? It's supposed to be 27, and which is a bad day.
No. Yeah.
So if we can do 27, maybe we can, if we get spec ready on the week of 11th-ish, then we may have a vote on the 20th and move the spec through the server work group and to the IC, right?
So are there set times that the IC will look at that, or is it whenever it's ready?
IC has every meeting every 6 weeks, as I recall. Okay. But they should process a good amount of spec before the summit in the January-ish. So I think that's the important last train to catch.
So because I just worry if we try to pull it into the December 20th, you've got Thanksgiving before it, you've got everybody getting ready for Christmas.
It's crazy tight, yeah.
We may not be able to get the type of review that we really want and kind of tie up those loose ends. Maybe we need to push it to like the second week in January. When everybody's back, then you're fresh. You can go back and catch some of those things that need to be touched.
Maybe let me work with John and other people to find out what's the cadence. I believe across the specs while showing up in the summit, but I think we are not behind in general. Like we have been working on for quite a while.
I think we should definitely support or present it in December. You know, whether it's ready or not, and how close, how much we push for a vote after that. Looking at the IC calendar, the IC vote is on January 25th, or the IC meeting is on January 25th, which actually would mean that the January server project meeting would be the 24th. So we could do an initial read on December, and then do an official on January 24th for the OCP for the IC on the 25th.
And that's really good timing, John, because if we do it on December 20th, now we have a month to go off and have people review it, take those comments, get it back into the spec, so that on the 24th and 25th, we have a much more polished presentation for that spec.
Sure.
Yeah.
And I think that's a good idea. I think I will also try to get a feedback going, not counting on 24th as feedback, because of the major stakeholders are almost meeting on a weekly basis.
Yep.
So 24th, I don't really expect any objection on that point. I will try to resolve the concerns or the trade-offs before that.
Yes, I agree.
Yeah.
Yeah, if we're planning to. Yeah, if we're planning to go to present on the 24th and go to the IC on the 25th, we have to have all the checklists and stuff pretty much done before the meeting on the 24th. That'll just be the official reading of what we're calling the final proposal. But we do need to present in November to get the community fully involved in reviewing.
So one question about the content of the spec. The one that will go in December or January, it's going to have mostly the physical aspects, right? We are not going to get all the system management and all of those. Is that a plan, or because then
if you can support before that would be great.
Okay, then we need to have a session like we are talking about.
We need that in there.
There is a placeholder in the chapter of the system management. I think you and you are volunteering. So
yeah. So we will probably need it, not today, but we need a session like this.
Yeah, you actually please go ahead. Let me know if you need help from me to set up the session or start your communication or talk to you offline. And about the content. Overall, I think we have a high-level principle for what to be put into management. We want it to be useful and not commonly useful and not overly regulated in general. But how to kind of set that line? You may try to use the email reflector to share your thoughts.
Yeah. I don't know if Bob's talked to you yet. So Bob Stevens is the Dell EMC Systems Management, but we've started circulating a list of what we think are required elements and optional elements based on things like thermal reporting and kind of using OCP and then trying to extrapolate what do we need to make it required so that you can take anybody's card and plug it in.
Yeah.
And so
we also identify those critical things for plug and play. Leave the thing that you can do differently out.
Absolutely. You need room to be proprietary, but fix a certain amount of that.
Because we've expanded the scope, I think we may have to, and we'll talk about this more. I'll send out some. We should start talking about profiles, because like those who are going to do like more long kind of profiles, your management requirement will be different than you're just going to do PCI NIC. So that's what I'm thinking in my head. At least we have those kind of profiles. And I have requirements around that.
We should probably set up weekly meetings, at least starting right after Thanksgiving. Maybe we can have one next week. I don't know. With everybody. I'll certainly be around. We'll make Bob join. And I'm sure you all can join. We do it early enough in the day.
Okay.
Okay. That's good.
Done. Okay. Amy, you have anything to bring up for thermal?
Yeah, so I think mainly is that we will update the thermal, like overall thermal decks into the wiki. And I want to gather some of the feedback about temperature reporting, like sensor accuracy, what's going to be converging, and also if we can do power reporting also. And another like big topic is the text picture. I think currently Dell, like Robert from Dell, like already proposed 2 options, and also like Jonathan will propose another option. So basically we have one is more like a system like text picture, so which is more representative of how the system will look like, and the other one is more towards the NIC only. So we are trying to converge into these 2 options. And one thing I want to highlight over here is that for the thermal reporting stack, we actually have 3 options or timelines. So one is that do we want to really put it into like together with the CAD drawing, together with the OCP mix, or the second option is that we kind of have a separate thermal reporting documentation and just have a link in the main spec. Or third is that the third option over here I listed is that if we define a general concept and the drawings and detail level definition fall into a separate one. So I'm not like just want to hear feedback to see how the community feel about the three approaches of this text feature reporting.
I always prefer a single spec if it's possible to do it.
Yeah, that's the benefit of everything is in one. The benefit of having separate spec is, let's say if you don't converge on the model for thermal reporting, you get some more time to really finalize those details and keep revving that piece while this spec. So there are pros and cons. I mean, if you go down the separate path, let's say just for the sake of discussion, then it might make sense to even break down the system management into separate spec and then have all the mechanical, not just for thermal. But I agree with John. It's generally one single spec has everything.
When you start breaking it up, then
Keeping it in sync is
never
one of the big problems.
think, and do I have the latest of all of them instead of just one? However, certainly if we can't converge, then we need to figure out what do we pull out and make a separate spec while keeping the same basic physical form factor so that our card vendors and the system guys can go off and actually design hardware.
Yeah, great. So this is like our common goal is to like push it
And keep the separate as a fallback. If we hit that point where.
And we ought to be able to come out of today with a list of here are the items that have to be done in order to finalize the technical details of the spec. Get people assigned to them across the community and put a timeline on it and say this has to be done by this date, and then try to drive towards that. And that should help us get it into one spec. And again, we'll probably hit 90–95%, but that's going to be a huge bonus, right? And frankly, we're not going to know all the details until we build systems and cards and start plugging them in and went, ooh, okay, we need to make a little change.
Okay.
Squirrel.
No,
fine.
That's my squirrel coming.
Yeah, okay,
So
like for this.
one other question on the scope of the specification. We were all focusing on network, but we know that there's going to be at least 2 or 3 other use cases. How are we going to address the other use cases? Are we just going to make it generic enough to allow them, or are we going to call out any other use cases?
I think the problem over here is that since both NIC vendor and system vendor will use the same concept, so we kind of want to keep it simple and easy adoption. So I think a generic one maybe more like towards, if we say it's more towards a representative text picture, then it can somehow represent the real life. So I think the idea is that first of all, keep it simple, and second, like make it be representative, and third is that we need to like consider both small and large form factors. So this is kind of our requirement for this text picture.
I think John was also talking about doing things like SAS or something else with different connectors. And I think that the answer there is, well, we're defining envelopes, connector openings, chassis openings, and there's a lot of area that people could go make proprietary solutions within those bounds, and it would still fit in a standard slot. But I think that we're not going to go find every use case and try to go do mechanical models and do it for the community, and allow those people that want to do something proprietary to go off and just use the volumes and the chassis mechanisms and everything that the NIC 3.0 will have in it.
Yeah, and I agree with that for external PCIe or external SAS, but as far as internal connectors, we really don't have any provisions on where to put those. I'm not sure those would fit inside the heatsink envelope, or do we account for cable exit inside? There's just a lot of things that we could bring up. We definitely don't want to go down all the way down that rat hole, but do we address it at all?
I certainly, so my perspective, and we work for the same company, is we don't slow down the specification that we're working on now to add that. It would need to be added later because we don't have spare time right now. And
no, we don't.
You know, we need to get this moving. But I agree. I think that that's probably something that a spec 3.1 or 3 point something could bring out is like, hey, if you wanted to do, you know, pull off the internal cables, here's a representative way you could do it. Because you're not going to be able to write a spec that says pull the cable off in this direction, because the first person that uses it will want the cable going the other direction.
Right.
But to me, the key is making sure we have one spec that covers all the areas that we want, with 90 to 95% of the use cases covered in a timely manner. You know, and it sounds like, you know, end of January is kind of where we're falling right now for something that could be ratified. And I think that, you know, from my perspective and Dell servers, that meets our requirements. It's right to the edge. We don't have a lot of, but I think the technical details will be done before that. So we have
helpful planning. We can provide whoever wants to adopt earlier, good enough confidence earlier, even without rectifying the spec itself. You can sense that it's so high confidence, and you can really not necessarily tape out something, but you can start to manage for that for some platforms.
And that's where we're going to be, right? We're going to be following along and making those final tweaks and getting it out the door.
Sounds good. All right, we're actually over 12 minutes, so is there any other question on the bridge?
This is Albert from Amphenol. Just on the OCP test fixture, is the thought to get like a third party to manage this, like UNH, the IOL lab, or how is this going to get managed?
So we need to discuss that. I've had some discussions with the guys at IOL, and they're certainly willing to talk to us about it and give us some type of third party. I think that the test fixtures themselves needed to be designed by the community because we're the technical experts in those areas. But having a third party lab set up with the test methodology might not be a bad plan, just like we do for Ethernet. That would give us some compliance resource that
you don't want to manage
that you're not doing this, right? And they certainly have the expertise to run that. And if we want, we can take a poll, and if people are interested, I can certainly, I don't know if you know the guys at IOL, but I know them well. We can have a conference call. And talk
I will try to see if something can come to me too.
Okay.
Later.
Perfect.
All right. So we probably will finish here and jump on the bridging for the working session. So thank you everyone. But I think most of the people will actually attending the working session will on the bridge. So we're just changing the bridge here.
Hey Gian, this is. Oh, go ahead.
Oh, is it the?
I just want to make a quick OCP announcement if you didn't mind.
Oh, please do.
Okay, I just wanted to let you all know that, hopefully you can see my screen here, that registration for the summit is now open. So you can go to our website at OCP and click on the summit, and then you can register. And here's the prices and the dates for that. And then also our call for participation is also open. And we are accepting session submissions for keynotes and engineering workshops. So please go ahead and check that out. And the survey will remain open until December 1st. So just a couple more weeks here. So we would love it if you all would take a minute to think about what you guys want to present and go ahead and fill out that survey with your information. It's got some other important dates on here about when speakers will be notified. But yeah, let us know if you have any questions. You can find the survey here on this page under Summit. It's also on our blog. But just wanted to let you know that's open and it closes on December 1st. Thank you.
And one last, this is Archana, so one last thing, our leadership sprint is coming up here on December 6th. It is going to be a remote leadership sprint for the IC and the project leads. And so if you have any inputs for the IC, please let the project leads know, and they can give that input at the leadership sprint when we meet in on December 7th.
That's the IC meeting? Is that the IC meeting?
It's the combined leadership sprint with all the project leads and the IC. So this is a great opportunity for the project leads to present any new proposals to the IC, as well as just talk about just general health of the community, any feedback that you have for the community. So just if you have any feedback, good or not so good, please let your project leads know. And then they will communicate that to the IC. So that's coming up on December 7th.
Sounds good.
Okay.
Yeah.
Thank you, Archana.
So those feedback may be pointed to John Stewie, right?
Yes.
Okay. Yeah. Okay. All right. Thank you for everyone. Thank you, Archana and Kali, for the hosting.
Of course. Thank you. Have a great day, everyone.